Good morning, everybody. My name is Stephen Bailey. I'm the Director of Data and Analytics at Immuta, and it's my pleasure today to talk to you about something that I think is really important, but data governance in the modern data ecosystem, and specifically around problems such as privacy and why data engineers need to be leaders in creating solutions that companies can actually implement in order to control these problems. I've split the talk into three topics. First, to just draw some parallels around the new data ecosystem and previous technological transformations and what we might need to adapt in this new ecosystem. Secondly, to think through some of the major players in how companies manage risks like privacy loss, and really dig deep on who is positioned to lead those initiatives. I don't think it'll surprise anyone to hear that it's going to be the data engineers. And then finally, to look at one specific area of modern data governance where privacy can be protected, and that is access control, and how metadata can play a key role in scaling that across your entire ecosystem. So let's first talk about the risks and opportunities in the new data ecosystem. I want to start with an analogy. So 150 years ago, the steam engine was a technological marvel. It transformed the economies across the world and really was a key piece of the industrial age economies and innovation therein. I think there's some really interesting parallels we can draw between the steam engine and maybe the first era of data. If you look at the steam engine, it's really a monolithic design. You have an inseparable relationship between the infrastructure and the vehicle. The cars, or really the value drivers, are attached to that steam engine, and that steam engine has to be managed by a single experienced professional driver. Everything has to be thought through. Like, you can't just, you can't just dream up a new railroad track and in 2 weeks you're going to have a train driving on it to another city. It's got to be there's a very high planning and implementation cost. If you think about our modern transportation ecosystem, you have this total separation of the infrastructure from the vehicles that are driving along it. And that decoupling facilitates just a much larger quantity of automobiles that can drive on, and also a much larger variety. So you have everything from, taxi cabs, bicycles, motorcycles, personal cars, trucks. Really, if you wanted to, you could drive a tank down the road. There's not really any relationship between the infrastructure and what's happening on top. That's led to a real democratization of the personal automobile. So pretty much anybody can pilot one of these very sophisticated vehicles without an incredible amount of training. And it works. It works, and that's why it's spread and been so impactful. Well, I think that, like our roadways, the modern data ecosystem bears a much closer resemblance to the modern roadways than it does to train tracks. There's no clear boundaries of responsibility anymore. The ease of portability, transformation, and the variety of tooling means that data consuming tools can quickly become data providers as well. It's all about interoperability. There's not a single monolithic data warehouse that the company took 3 years to plan and built a team around and hired very specialized people to manage it. In basically 2 weeks, a team could decide that they want to spin up a Snowflake database, start ingesting data into it, and have like 15 SaaS apps connected, and delivering high quality data into an analytic tool. It's the world has really flipped on its head. One consequence of that is that the variety of tooling that's available and the complexity of the whole ecosystem has exploded. This is a diagram from an Andreessen Horowitz article on H16Z that shows the modern data ecosystem. You can see from left to right at the top, there's a general pattern here of like you have data and sources, you transform it, you store it, then you can do like certain types of analyses on it and it outputs in a dashboard or a report or something like that. But there's bidirectional arrows everywhere. You've got things like feeding into each other from within the same area. It's chaos. Not unlike New York City at rush hour. It takes a trained person and someone kind of brave to want to drive around in New York City at rush hour. Someone certainly braver than me. But the same is true for people who want to start digging into and innovating within a modern data ecosystem. One of the big points here, though, is that it's not like highways, it's not like it was just a technological transformation that took us from trains to cars. There were a lot of changes to the infrastructure, the way we build cities and the way we plan cities. A lot of changes to oversight and supervisory capacities. We have patrol cars and emergency services, signs everywhere, stoplights. And we have processes. So human behavior, it's a big thing when someone becomes able to drive. We could make getting access to the warehouse a big celebratory thing. Like, hey, you've become a power data user and you're like special now. Car insurance is another thing. It's like these whole industries have built up around in order to make riding on this infrastructure safe. In the same way, we need a better way to govern the whole data ecosystem because there's so many new risks that are posed. The title of this talk is specifically about privacy, but and that is probably the most prominent human issue that's at play. People's personal data is just scattered through all these systems, and that can present economic risks. Where if the data is not high quality, if it's not protected, company can get fined. But also culturally, like if we feel like a company feels like they're not protecting employees, or if they're like abusing employee data or customer data, that is unsettling. And human risks. So there's real costs to privacy violations, security breaches, and unethical use of data to the people whose data that is. So our world has changed, but I would say our sort of mental template as a community that uses data has not changed along with it. And we need a better way to govern this data ecosystem to minimize all these risks. So who are these people who are going to be able to improve our data governance standards to help us create safe roadways for leveraging data to bring as much value as we really want to get out of it? Well, there's at least 4 big sets of players that I've listed here. On the left-hand side, we have regulators and lawmakers. These folks are trying to create far-reaching standards that can be broadly applicable. The sort of things that come to mind initially are GDPR, HIPAA, California Consumer Privacy Act. These big regulations, they set the standards that companies have to start adhering to. But they also might miss the mark on being very prescriptive. So there's a lot of holes that have to be filled in. The next group is compliance and information security. They set company processes, they set standards, and they audit adherence to them. There are internal enforcement of the company's stated standards and agreements with external companies, whether that's regulators or auditors. The next group is business owners and data consumers. So the people who are in the trenches, creating, producing, procuring, bringing value out of data assets across the company, basically the ones who are getting a return on the investment in our data assets. And finally, we have data engineers and platform owners, the people who are mostly technical. Their concerns are about building platforms that can drive value across the organization, either internally or also externally, more and more. Well, let's talk about like what the limitations are with each of these groups. So for regulators and lawmakers, they might have a great standard. They might even be aspirational, ambitious, that we want to create a country that protects people's data. But there's a lot of gaps to fill in. They might not have an implementation plan that's ready to go. Some things like anonymized data might not even have a clear definition that engineers can just go through and implement. Compliance and information security, similarly, while for areas of the business that have been around for a while, or for very clear external standards, they might be able to put into the place a very clear process. A lot of the stuff that's coming down the pipe in the new data ecosystem is brand new. There might not be a playbook out there that the company wants to commit to following and building a really, really strong process around. Things like fairness, the exact definition of what is identifiable data and how that should be handled. There's a sort of a softer layer right now as new things come out that compliance and information security may not be yet able or ready to build a process around. The business owners and data consumers are so focused on bringing value to their projects, to their lines of business, that they may not operate with the whole big picture in the mind. And they also may lack some of the technical skills around how to make a scalable system. And so even though they might be key partners, they may not be positioned to create standards that scale. And finally, the data engineers and platform owners, these are the people I think that are really equipped to bring a modern data governance at play. They're experts at architecting systems. That's their job. They sit at the cutting edge of technology. They're always looking for new things coming down the pipe that are going to generate value. And they're incentivized to build for scale and reliability. They are not incentivized to solve today's problem. They are really thinking long-term and big picture, hopefully. There's a great quote from this book, Data Management at Scale, that talks about how a large part of data governance work involves defining principles, policies, rules, and standards that fit the enterprise's goals and risk appetite. And these principles, policies, rules, and standards, they have to be enforceable. They have to be implementable. Otherwise, they're just pieces of paper in a drawer. And I think only data engineers are technically equipped to operation and scale principles, policies, rules, and standards. The new data ecosystem presents a lot of technical problems that have to have a technical solution, or have to have a solution that's at least technically sound. It's not going to be, a simple like data catalog or Word document that everyone puts in their data assets and what data is sensitive. There's got to be real technical backbone to any solution that comes out here. So when we think about privacy and we think about all these interrelationships between systems, where does privacy protection happen? Does it happen in any like a single node in this graph? Well, in this article or in this diagram, there's 4 things that I would call governance functions, governance capabilities, and they're all kind of situated at the side of this diagram. They're broken into metadata management, quality and testing, entitlements and security, and observability. And I think what you'll see, if you think about it, is all of these things have to do with principles, policies, rules, and standards. And they're also driven by metadata. Quality and testing is you're creating a metadata, a framework that you want to evaluate data assets against. Metadata management is all about defining and coming up with vocabularies and discoverability of assets using metadata. Observability is about looking at all of the things that are happening across all these different pipelines and coming up with actionable intel. And then what I'm going to drill in on is entitlements and security, which is using metadata to enable access and protect assets, using metadata about who people are and what they're trying to access, and enforcing policies based on it. So in other words, data engineers, as they think about their entire data ecosystem, they need to be thinking about the metadata layer that is one step above infrastructure, but one step below the actual data products. All right. So to close out with, I want to dive into one area, which is our company's specialty at Immuta. We focus on entitlements and security and how metadata can drive these policies to make it a more scalable system across projects, across technologies, across policy types. And one thing I want to point out here is that access control is really one of the original metadata-driven governance problems. When you think about early databases, what's one of the first things that they put in there? It was roles and groups about who belongs to what and what they can access. And a lot of times these were baked directly into the database because you only had one database. In the modern ecosystem, you have an identity manager that might be federated across all of your systems, soaking in data and powering access to different systems. That's really the starting place for a modern entitlements and security solution. So I want to talk about three things that if we focus on building a really robust metadata layer, there's a couple of things we can accomplish. The first is we can abstract access policy from underlying technology and projects. We can establish a better language around what we're doing. I think that's one thing that's very underrated is the language that currently exists around access control is so hard to understand for a regular person. Metadata can help make that more accessible. And then dynamically injecting context into control systems and make them much faster and more dynamic. So when we think about putting policy, applying policy like, hey, only certain users can access personal data, a lot of times we think about the transformation layer. So in a lot of data pipelines, you have transformations that are designed to make a product better, like standardization, aggregation, data cleaning, denormalization. And a lot of times, personal data protections will be kind of baked into the product there. Or they'll be baked into the report that's generated at the outside. These types of baked-in transformations, I'm calling governance transformations. They're things like access control, row-level security, identifier masking, data minimization, even higher-level things like k-anonymization or differential privacy. And I want to walk through a scenario where a team kind of grows up, a small team kind of grows up, and show you the pain points here. So at a small scale, teams can get by with having almost no access control. So here we have a database, you got bronze data being transformed to gold data, and it's being released basically to everyone in the company because that's what you do when you're small. Oftentimes, you'll start saying, hey, we've got some data we need to start protecting, and only the executives can see it, or only a certain group can see it. So you start breaking the gold data apart into two, and you give different people access to it. And then there start to be more requirements that start coming up. So you might have to restrict access to some resources, sometimes only for certain projects or certain reports. There might be another group that gets involved. And so basically complexity starts getting built into the pipeline. But if you are able to defer the policy implementation until later, either through, what I'm showing here is the Immuta policy engine, but there's a lot of other tools that are coming out, even those kind of managed by the cloud data warehouses. You're able to abstract the transformations from the transformations for governance from the transformations for utility, which simplifies access to all of your interested parties. Similarly, if you're thinking about a warehouse that you've implemented some controls, you're happy with it, But then, your vendor increases prices, or you're spending way more than you expected to, and you want to switch to a different system or switch some of the workload. Well, all of those transformations that you've put into place here now have to get retranslated into another database language. They get re-implemented. You're now governing 3 systems. That creates a lot of challenges. But if we treated governance transformations in the same way that we treat identity management, for example, then you should be able to push down these transformations into a single access layer that allows personal data to be masked. But it's all dependent on being able to tag or identify certain types of data across platforms and then implement a rule specific to that type of data on those platforms. But you can see the clear value add. Secondly, policy can become very complex. And one of the best things that you can do as an organization is to have clear guidelines around what is expected of data products, who can access these things, what they are, and what you mean when you say, for example, personal data or sensitive data. It's not a trivial task to come up with this definition. A mature metadata framework is going to have things like, it's going to enumerate exactly what you need to be concerned about and what needs to happen with that type of data. It's access control models, one of the most familiar one to most people is role-based access controls, and that can get you a good bit of the way. Attribute-based access controls, as you can see on this diagram to the right, allow an increasingly finer granularity of access controls, because instead of focusing just on roles, you're focusing on, you're actually defining the objects and the attributes that need to that need to power the rules. So they enable more complex policies at a finer granularity, but they also can be more readable as well. But there's another class of access controls where you start implementing policy-based access controls, where you're giving a more transparent rationale for access decisions, and they're easier to follow. So a lot of times they'll implement attribute-based access control rules, but they're providing a reason and a rationale for why they're being implemented. And that's not negligible. That value add is not negligible. The clearer we are with why we're doing something, the more likely it is to be followed, and the easier it is to onboard new people into that system. And the proper metadata framework can really allow a lot of flexibility. This is an example from our Immuta policy engine, where you can really understand what's happening here. So in the second line item, we're masking columns that are tagged a direct identifier by making it null for everyone except when user is acting under a certain purpose. So it creates a much clearer policy than some allow, accept, block, IAM policy, or IAM policy. And finally, my final example is I want to talk about context. One of the things that we don't talk a lot about, but is written into a lot of these laws is you have to actually be thinking about why data is being used and tracking that. You can't just use data for any reason. Although we have some tools at our disposal, things like roles, it's very hard to understand why a certain data analyst was using a certain piece of data and then attribute that. There are let's say organizational ways to handle this. In academia, you have institutional review boards. There's data privacy impact assessments that can outline why and how data will be used and what the consequences are. Certain projects may be amenable to things like model cards and data sheets, which are really great tools for identifying risks in data. But we don't really have a standard way of going about doing and evaluating why data is being used. And a dedicated governance layer can start to enable that. If people, in the Immuta product, there are concepts called purposes, which users can switch into and out of, and they will actually enable access to certain data assets or enable access to some forms of personal data of access. So for example, if you're acting under an analytical purpose, you might only get fully anonymized data. Whereas if you're acting under an auditing purpose, you could get access to data that is fully in the clear. And it also gives a hook for data governors to kind of step in and review an access request. So building in workflows around access control allows us a lot better. It gives organizations a way to step in and make decisions about when and how data can be used. All of these innovations are reliant on metadata. You have to have your policies defined, knowing what you want to do. You need to have a comprehensible language around policy that everyone in the company can rally around, and you need to be thinking about what are our workflows and processes, and when should data be being used for a certain purpose. And if you unite them in a metadata solution or a data engineering, a metadata solution that is scalable and robust, that is battle hardened by data engineers, well, now you have a real good entry point into modern data governance. And the same can be true for these other capabilities: metadata management, data quality, observability. All of these things are important to ethical use of data, and they need to be prepared to scale along with the organization, because we're in a new data ecosystem, and it presents a lot of technical challenges. Just a closing thought, as we think, just like roadways, the future for all of our organizations is connected. All of this data sharing initiatives means that we're going to be driving on each other's data highways sooner rather than later. I've gotten a lot of requests from vendors who want to do data shares with us, and instead of going through an application, we're just going to share data directly. We all need to start thinking about the conventions that need to be established so that we can maximize value and minimize risk. I think that only data engineers are the ones who are capable of coming up with those standards and principles that can then be enforced and followed by other stakeholders in the ecosystem. But it's really on us as technical professionals to be leaders in figuring out what's going to work well so that we can all participate in this new economy safely. Thank you so much.